Welcome everyone. Today I am going to present a video about obstacle avoiding vehicle. So the content of this video is going to be like this: objectives, components required, circuit explanation, the motor driver circuit, servo motor construction and interface with Arduino Uno, ultrasonic sensor, how it works and the code, and the final code of all together, the motor driver, servo motor, ultrasonic sensor together. Okay, and we will see the demonstration of the project what we have done. So objective for an obstacle avoiding vehicle is very simple. We have to design a vehicle which should identify the obstacle and it has to avoid collision with a foreign object, and it has to adjust the path and adapt to the environment conditions, and these things should happen in a quicker way. It should not react after it is hitting the block or the any object which is in front. So this is the objective of this particular project. The components required is I am going to use L298N motor driver, so which can drive two DC motors, and the Arduino is the controller, ultrasonic sensor to measure the distance between the obstacle and the vehicle, servo motor to rotate the head and check the obstacle which is going to be in front or in either side of the vehicle, right or left. Two 5-volt gear motors with wheels to propel the vehicle. The body or structure of the vehicle, so which gives a shape for this project. I have used 7.4 volt lithium ion battery. So if you have 9-volt battery, you can use it, or you can use the higher voltage batteries and you can step down using step down converters like buck converters, right? So this is the circuit or wiring diagram of our proposed autonomous vehicle. Very simple one. I am going to have a Arduino Uno and a motor driver IC L293D. Actually I have shown here IC, but I have used a module, and two motors to propel the vehicle, to gear the DC motor, 5-volt motors, and one ultrasonic sensor HC SR04 and one servo and 9-volt battery. Here it is not actually 9-volt battery. I have used a 7.4 volt battery, which is sufficient enough to drive all these things, right? Controlling a DC motor. So we know that if you say control, that means it can be two categories. One, the speed control, the other one, the direction control. How to control the speed of a DC motor? It's a simple method is to control the voltage, either increase or decrease the voltage so that the speed can be controlled. So this we can achieve using pulse width modulation. So where the Arduino has the pulse width modulation pins, so we can use this PWM pins so that it can control the speed. And the direction can be controlled by using a H bridge. So I will discuss little broad about this H bridge little later or on the upcoming slides. So the direction can be controlled using this. So when you have the control of direction as well as the speed, you can control the vehicle moving speed, also the direction. So this is the objective of having these two controls. So let us understand what is pulse width modulation to control the speed. If you see, this is a 0 to 9-volt peak signal, and I have on time and off time for completing one cycle. Okay, so in this on time is 10% and the remaining off time is 90%, So that means I will get only 10% of the applied peak voltage or the full voltage. So that means I will get 0.9 volt when I am giving the pulse like this. Or if I give the pulse in this way, the on time is 50% and off time is 50%. So this means my average increases from 0.9 to 4.5 volt. So this means it will directly impact the speed of the motor. So here it will run very slow or it may not run as well. Here when you are reaching to 50%, then it means you reach 4.5 volt for theoretical calculation here. So this 4.5 volt off of the rated speed the motor can run. And similarly, when you increase the pulse width on time to 90% and off time to 10%, so you reach almost 8.1 volt. So this means you are achieving near to the closer speed or the maximum speed. So by doing this you can control the speed. So by varying the width of the pulse on time and off time, that duty cycle, you can say duty cycle, by varying the duty cycle of this pulse, so you can control the speed of the motor. For controlling the spinning direction, I am going to have two H bridge in my L298 module. One H bridge is going to control one motor, the another one is going to control another motor. I am going to use two motors, so I am going to use two H bridges which will be inbuilt or inside the L298 module. Okay, how it works, if you see, it consists of four switches. Here they have shown transistor, it can be a MOSFET or it can be IGBT, depends upon the current rating. This switching device can be different, but the concept remains same. So in these four switches, by turning on and turning off the switch pair in a reverse direction, you can change the direction of current. For example, you see the picture B, the Q1 and Q4 is turned on and Q2, Q4, Q3 is in off condition. So this means the current flow direction goes from A to B in the motor. So this makes the motor to run in one direction. When you want to change the direction to opposite, so you turn off the remaining two. Actually in the picture it is not shown correctly. It will be like this. So you turn on this and turn on this. So what happens now? The current will flow from here to here. The direction is shown here, but actually it should be closed here. This should be closed and this will be open and this will be also open. Okay, so the current flow takes place in this route, so that the direction of current in the coils will be in opposite to the previous one. So the direction of motor also will be in opposite side. So based upon the current requirement, the switch what we are using here can be changed from transistor or power transistor, then MOSFET or IGBT or any other power devices. Okay, so that is how the direction of speed can be, direction of the spinning of the motor can be changed. So L298N motor driver chip or the module consists of two standard H bridge, as I told you little earlier, two standard H bridge, and it is ideal for controlling two-wheeled robotic platforms. So this is what we are going to do. So that's why we are going to use this L298 motor driver, and it can give 2 ampere in each channel. So that means for each motor it can give 2 amperes continuously. So the motor rating, when you are controlling the vehicle size, or when you are deciding the vehicle size and the weight and things like that, so you can take this into consideration. So if you are using the motor with a 2 amperes current, so how much size you can take. If you are overloading it, then the motors will get not enough current and it will produce heat in this IC. Okay, so this is the very important factor for deciding the size of the vehicle. In case if you have a big size vehicle, then we can use 4 motors. so that each wheel will have 2 ampere capacity, so it can carry more load. Technical specification, as I shown little earlier, so we can give 2 amperes current, and the operating voltage, the logic voltage is 5 to 7 volt, and the motors which we can connect is up to 35 volt, 5 volt to 35 volt. In general, for our small robotic applications, we will use 5 volt to 12 volt motors maximum, so that it can propel the road tires, so that it can move, the vehicle can move. So the module which I used is look like this, which has power terminals here, so 12 volt ground and plus 5 volt. So I am going to use this 2 terminal plus 12 volt and ground. I am not going to use this 5 volt input, so I am going to use this one. And here we have the control pins. For 2 motors we have 2 set of control pins. So one enable A, IN1, IN2. So this, by using these 3 pin, we can control the speed and direction of the first motor. The remaining 3 pins can be used for controlling the direction and speed of the another motor. Where we are going to connect the motor? So we are going to connect the motor in this terminals. Output 3 and 4, one motor, output 1 and 2, another motor. So this is the connection requirement for this module. Okay, so this is the same point what I discussed earlier. So if you are using this 12 volt input and ground, so you can see here there is one jumper placed here. So by giving this jumper, you are enabling the regulator inside this board, so that it can give 5 volt output. Here it can give 5 volt output. In case if you are taking the power supply for the Arduino, you can take from here itself, from here 5 volt and here ground. So by taking this, you can connect the Arduino power supply also. So this is possible. Suppose if you are giving 12 volt and ground here, and you need 5 volt, there is a regulator. So this enable the regulator inside this board, so that it can give 5 volt output here. Okay, but I am not going to use like that. So since I am powering the Arduino separately, I am not going to take the supply from this board. Okay, how to turn on and turn off the motor using this module? So it is given, we have input 1 and input 2 for controlling the the turn on and turn on process only I am going to discuss now. So if you give the input 1 and input 2 both 0 0, so that means, say for example, you connect this pin in pin number 13 and this one connected in pin number 12. So by giving 0 and 0 in both pins in the Arduino, in the code, what will happen? The motor will be in off state. When you want to make the motor on and rotate in one direction, either clockwise or anti-clockwise direction, based upon the way you connect it in the the board. So here the input 1 is considered as 1 and the input 2 is considered 0, so which will make the motor to run in, say for example, clockwise direction. And in the reverse, if you make the input 1 0 and input 2 1, so this will make the motor to run in the opposite direction, say in anti-clockwise direction. Keeping both the inputs in I condition also make the motor in off condition only. So to turn off the motor, I am going to keep low low and keep the motor running in forward direction. I am going to keep 1 and 0, and for reversing it I am going to keep 0 and 1. So these are the states of the input what I am going to give here at input 1, input 2 and enable. So the enable, I will tell you what you will do with this enable pin. So the speed control pins enable A and enable P are used to turn on and off the motor and control their speed. It is also possible to turn on and turn off the motor by using this enable A and enable B. So to control the speed as well, we can make use of these pins. We will see a small code, so there I will show you how this enable A and enable B is used to control the speed. So this is the wiring diagram for connecting two motors with this L293D and Arduino. You can take any Arduino, no issue with this. Actually, I have connected all the pins, like enable pin, input 1, input 2 for one motor, and enable B, and input 3 and input 4 for the second motor, so that it can control speed as well as the direction. And the power supply is given, the 12 volt adapter is used, and power supply is given here. Right. We will see a simple code using this L298. So we have to first define these pins. The enable A, I have connected to pin number 9 of Arduino board, and input 1 and input 2 is connected to pin number 8 and pin number 7 of Arduino board respectively. And for the second motor, pin number 3, 4, 5, these three pins are used to connect the enable input 3 and input 4 respectively. In this, these pins, whether it is going to act as an input or output, so we have to declare in the setup. So what all the pins are going to act as a outputs. Okay, all the pins are going to be used as a output. So enable A, enable B, input 1, input 2, input 3, input 4, all are acting as a output. Then in the setup itself, I make the motor, both motor in off state. So I just give low for all the inputs, so that the motor in off state when we are starting the process. Then we will go to the loop. In the loop we have direction control and speed control loops. The direction control loop, when the function is called, then it will go to this direction control. So it will come here, so where you have digital write for inputs. So input 1, input 2, input 3, input 4. So here low I and low high. So this is going to be in one direction. And when you want to change the motor direction to the other way, the digital write input 1 high and low, I low. So that means this is going to be forward, the other side is going to be reverse. And for enabling the speed control, I need to write analog write enable A and 255, enable B 255. This means this 255 is the maximum speed which the motor can run. So because of this Arduino Uno, this is 255. If you are using any other board, the maximum values can be different, 1024 or 4000 plus values. So that will be different based on the size of the registers. Okay, for Arduino Uno it is 255, and this 255 is the maximum speed. In case if you want only 50% of the speed, okay, you want only 50% of the speed, it has to move medium speed, then that means you will write 128 or 127 here. So based on the speed requirement, you can change this number. So based on that, it will move slowly or fast. Okay, so this is for controlling the speed. And in case if you want to control the acceleration in the beginning or the end, so you can also write it in the loop, the same 256. You will increment slowly from 0 to 256. So that means enable A and enable B, both the values are slowly increases. The speed increases from 0 to maximum, and then when it is decelerating, again from maximum to 0, it will decrease slowly. It will not suddenly stop, or it will not suddenly pick up. So when you have this acceleration from 0 to maximum, you will have a smooth startup and smooth stop. So this is also possible in the L293D. Then the next component what we are going to use in our project is the servo motor. We will see how the servo motor works and how it is precise, and what is the difference between a normal DC motor and this servo motor. Here also we are having a small DC motor here, the DC motor, and we have a control unit here. Then we have some gear mechanisms, and very importantly we have a sensor to position or to find the position of the motor shaft. So the basic difference between a DC motor and this motor is that it is a closed loop system, and in a DC motor it is a open loop system. So whatever the position the DC motor is in, it will not be able to identify because there is no feedback mechanism in a normal geared DC motors. But for servo motor, the purpose of having servo motor is to control the position, how much distance you moved or how much angle it moved. So we want to exactly stop the motor at 10 degrees, 20 degrees, 30 degrees, or in terms of linear movement, maybe 5 centimeter, 10 centimeter, like that. Oh, so for achieving this exact positioning, so we need to have the shaft position or the angle, so that the control unit can give the signal to either run in forward or run in reverse, or it has to halt. Anything can be possible using this control unit. So this is the difference between a normal motor and a servo motor. So how this is being achieved, we are going to have a control unit, and in the control unit again we have a H bridge, same like before. As I told you, we have 4 switches, because we need to have a both direction controls. It has to move forward as well as it has to run in a reverse side. And we have a comparator and the sensing device, that is potentiometer, and this potentiometer is connected directly to the motor shaft, so that it can position the motor shaft, and it gives the feedback to the error amplifier, and the pulse is coming from the Arduino. What is the position? Say for example 10 degrees I want to stop, this is my input, and here the motor position may be at say for example it is 2 degrees at present now. So the difference is the comparator compares this, and it gives the difference is 8 degrees. So that means the motor can run in a positive direction, and the direction will be achieved in the H bridge, and the motor runs in the same direction until it reaches to 0 degree difference. So this is how the control function is achieved in the servo motor. And in the servo motor also we can control the speed as well as the the position. So as I told you little earlier, the pulse width modulation is used here also in the servo motors. So this is a simple wiring. The servo motor, the mini servo motors will have 3 wires, which is power supply, ground, and the control wire. So the control wire will be connected to Arduino, and the remaining 2 will be connected to power supply. 5-volt power supply or 6-volt maximum can be connected to the servo as per the spec. So this is a simple code for the servo motor, where I attach one header file. So it's a default header file in the Arduino IDE. It is available. If not available, you can include the servo header file in your Arduino IDE, include servo.h, and I attach servo in pin number 9, and this is a variable, servo variable, and angle, initial angle is 0, and I attach that servo pin to the servo. Then in the loop I am going to make the motor to run from 0 to 180 degree, and then it will come back from 180 to 0 degree. So it will sweep positive and negative. There is a for loop for increasing slowly, 0, 1, 2, 3, D, 4, like that. You can increase the angles with 15 milliseconds delay, and once it reaches to 180, then the loop will exit from here and it will start the loop from here. So from 180 it will come to 0 degree angle. Ultrasonic sensor, this sensor is used to measure the distance. We are going to measure the distance between the obstacle and our vehicle. So it is very important for us. The objective of our robot is to avoid the obstacles, right? So we need to measure the distance. The formula used here is the distance equals to speed of sound into time delay or time taken divided by 2. So this is the formula. It's a default formula. How this ultrasonic sensor works, we have 2 pins, that is a trigger pin and echo pin, and the supply VCC and ground we have. When we give the supply to this, VCC and ground, and when we give the signal in the trigger pin, you give a small pulse, and this pulse will produce the ultrasonic waves. Like this, ultrasonic waves will be produced, and these waves will be transmitting in the air until it reaches to any obstacle. It will not return back. When it reaches to any obstacle or any object, then it will return back. So that means the sound signal has to go in a forward direction and it has to return to the same ultrasonic sensor itself. So here, because of trigger pin, the sound wave is produced, and then when it is coming back, because of the object, it is reflecting and it is coming back. In this picture you can see the red color one is the signal which is generated from the sender or the ultrasonic sensor, and after hitting the object, the reflected signal is shown in the green color. So the time taken for traveling from the sensor to the object and then from the object to the sensor, so that's why we make it divided by 2. Okay, the time total time divided by 2. Right, so the wiring diagram is given here. It's very simple. So we have VCC, ground, trigger and echo. So trigger will be considered as the output, and echo will be considered as the input. So this is the code just to measure the distance between the object and sensor. So I am going to use 2 pins for connecting trigger and echo, pin number 9 and pin number 10, and I am declaring some variables here. Duration and distance, that is the time taken, and the exact distance, that's 2 variables I declare here. And in the setup I am going to say the trigger pin is output, so because it has to give the pulse, and this pulse only is going to produce the ultrasonic signal from the ultrasonic sensor. And echo pin, which is going to receive the reflected signal from the sensor, so that means it is going to act as an input. And I am going to print the data, that is distance and duration. So I am going to begin a serial begin. In the loop, what you are going to do is first set the trigger pin low, so that means like this, and then this is for 2 microseconds, and after that you set the trigger pin high like this, keep it for 10 microseconds, and then again make it low. So that means you produce one pulse. So once you produce the pulse and give it to the ultrasonic sensor, it will produce the ultrasonic sound waves. So this has to go to the object and it will be waiting now to get the signal to come back. So once it is come back, how much time it taken to go and come back will be measured in using the function called pulse in. Using this pulse in function, you can measure the time taken for reaching the object and coming back to the sensor. So this time duration will be measured. Okay, so that is a duration, and that will be put into the formula as I told you little earlier, duration into 0.034 divided by 2. Okay, so once we get this, we will get a distance in centimeter, and we can display this in a serial monitor. So this is the overall circuit or a wiring diagram as I told you little earlier. So this servo motor is going to hold this ultrasonic sensor, so that when the servo motor rotates, so the ultrasonic sensor also can move from left to right, and also it can check the front view, side views. So 180 degrees it can cover any object in this 180 degrees, so that the vehicle can move according to the direction. So this is the implemented project of the vehicle. We have Arduino Uno here, and the motor driver here, and servo, and then we have ultrasonic sensor here. So this base I have purchased from Amazon, and this tire materials, all those things I purchased from Amazon. Just I assembled it, and I make the code as per my requirements. Okay, so this is our final code. So where I have included all the above codes, whatever I explained earlier, all those things I included. Like I included ultrasonic sensor here, servo here, and for the motor pin I declared all the motors, 2 motors. I am not going to use a enable pin here. I am not going to control the speed of the motors. If you need, you can control the speed. I just want to control the direction, so that I used only 4 pins of the motor driver, and for ultrasonic sensor, pin number 7 and 8 I used as a echo and trigger pin, and I declare some variables here: front distance how much, left distance how much, right distance how much, and what is the maximum distance between the object and this one is allowed. So these are all the variables I declared here. Ultrasonic sensor, distance sensor, trigger echo, initialize the sensor. So this is it is coming as inbuilt for this header file. And servo positions, initial position is declared as 0, and in the setup we are going to declare first these are all output pins. Okay, so these are all for the motors, motor one, all these pins are output pin, and attach the servo here. Initial position keep it as 90, so I'm just going to keep this as 90 position. So this you can keep as per your requirement. And yeah, then we are coming to the loop. So first we have this loop for measuring the distance. So based on the distance only, it is going to decide whether it is going to go forward, or it is going to come reverse, or it is going to move left or right. So first measure the distance, and then compare that distance with the maximum distance. So front distance less than maximum distance, then it will go to the loop inside, stop, and it will go to the reverse. Then get the distance again. So the get distance again, this loop, this function will go to the ultrasonic sensor distance measurement, and stop. This is again having a function there, I will show you, and this back also having the function. So this means when you are entering here, it will call the functions. First it will call the stop function, then it will go to the reverse or back function, and then get the distance again. And now you are getting the distance again. Now you will check the right distance and greater than maximum distance. If the right distance is greater than maximum distance, then it will go inside of call the right function, and then make a forward motion. If this condition not satisfied, then left side it will check. Left distance is greater than maximum distance, then that means the left function will be called, and it will make a forward motion. Then these all conditions failed, then what happens? Then it will go to this else function, so it will take a reverse. That means it will come back. So that means the object in the front, in the both sides, so it cannot go further either in forward direction or in either side. So that means it will take a reverse. If this all condition fails, then without any obstacle, that means there is no obstacles, so it will make a forward motion. So these are the functions. For each function I have written a the instructions, what should happen when forward happens, what should happen when the right function calls, when left function calls, and back and stop function. For forward, I am going to keep both the motors run in a clockwise direction, high low, and for right I am going to keep one motor in both off state and one motor in forward, so that it can take right. For left, just opposite. So first here you will keep one motor low and the other motor high, so that it can take the diversion in the other direction. For reverse, what you will do, so here you gave high low, so you will give here low high, so that it will run in a opposite direction, so it will reverse. For stop, as we discussed earlier, all the input pins will be low. So when we give this, so the motor will be in off state. So this is the code. And for get distance function, so we are going to have the servo motor as to rotate in three distinct positions. So one is full right, and another one is full left, and another one is in the center position. So these three positions, that is right, front and left position, it has to take the distance between the obstacle and object. Servo 1 right is 0 position, so that means the servo will rotate to the 0-degree angle, and now you measure the distance. Right distance is equals to distance sensor dot measure distance in centimeter of function. So when we call this function, it will measure the distance, and it will save in this right D memory location. And then servo 1 dot right 30, so that means from 0 it will move to 30, then 60, and then it will go to 90. So this is our front position. So I can directly write here 90 position, 90, but to make it little smoother, I just made 30, 60 and 90. Then when it comes to 90, what happens here? the distance again measured between the object and sensor in the front. Okay, so now uh, again once the distance is measured, then it goes to 120, 150 and 190. That means the left position. In this position again the distance will be measured. Now we will see if there is no object either in front or left or right, so that means all the values will be greater than the maximum limit what we have given. So that means it will go forward. In case if you the forward sensor is forward distance, when you find there is an object, that means the maximum distance, and this one when you compare, then the distance between the object and sensor is lesser than the maximum allowed distance. That means it will take either left or right. So how it will decide whether left or right? It will compare the left distance and right distance. So which one is having more distance, then that side it will move. So if all the direction, if you have objects, so that means it will take a reverse. So this is how the obstacle avoiding robot functions. It's a simple one, but a very interesting one. Hope you will try by yourself. Thank you so much for patiently listening and watching the video. Thank you.